What's up, everyone? Happy Tuesday, the 8th of January, and we're back with another functional programming challenge. Today, we're doing the triangle problem in Exercism Elixir. So Exercism is a little program, well, it's a site that you can use to practice various programming languages. We're on the Elixir track today. Elixir is a functional programming language that I really like to use. All of these problems I'll solve live in front of you. I haven't seen this problem. I don't know how difficult it will be. It may take me 15 minutes. It may take me 2 hours, but I'm going to do it until it's done, and you're going to see me live. Basically, you'll be able to see how I approach the problem, one, with a functional program perspective, and two, in Elixir. So let's jump straight in. I'm going to download the problem, jump into iTerm, and I'm just going to paste in the little command that I can copy from the page there, and then we'll jump over into VS Code and actually open the problem. So the problem we're doing today is triangle, and we'll open that up in VS Code. Take a look at the README and determine what we actually need to do to solve the problem. So let's jump into the README. Triangle. Determine if a triangle is equilateral, isosceles, or scalene. An equilateral triangle has all three sides the same length. An isosceles triangle has at least two sides the same length. It is sometimes specified as having exactly two sides the same length, but for the purposes of this exercise, we'll say at least two. A scalene triangle has all sides of different lengths. Note, for a shape to be a triangle at all sides have to be of length greater than 0, and the sum of the lengths of any two sides must be greater than or equal to the length of the third side. See triangle inequality. Let's just take a look at that, and we'll see what that means. I think that's got to do with, is it Pythagoras, or is that just right angle triangles? Any triangle, the sum of the lengths of any two sides must be greater than or equal to the length of the remaining side. Okay. I see. Okay, z is greater than x or y. Okay. X, y, z. Okay, that must be when they're all equal and approximately equal to x plus y. I see. All right, whatever. We'll jump in and actually take a look at the tests, dig deeper. The case where the sum of the lengths of two sides equals that of the third case is known as a degenerate triangle. It's a bit insulting. It has zero area and looks like a single line. I see. Yeah, x plus y is equal to z. That's only if the angles are zero. Feel free to add your own code/tests to check for degenerate triangles. So we'll see how long this programming challenge takes, and maybe we'll do that as well. So as always, I'm just going to copy that little command to run the tests, and we can see that the test file is named correctly, but we have one test failing because we haven't implemented anything. I'll take a look at the tests as well, just to make sure that I have some idea of what the function expects to return and any sort of error cases that we may have. So as we can see at the top here, triangle.kind222 is okay and equilateral. So equilateral being that they all have the same length. We have equilateral again. Triangle kind isosceles. So isosceles, if you remember back to the README, was two sides the same. Let's have a look here. Isosceles as well, two sides the same. Let's go down to the error cases and take a look. We have the scalene here as well. That's where all sides are different. So all sides must be positive. Okay, so that's our first error. So if we're passing in anything equal to or less than 0, okay, equal to or less than 0, you can see here that -5 is less than 0. Okay, this violates the triangle inequality, which is, so I guess the longest side has to be less than or equal to the sum of the other sides. Sorry, greater than or equal to. That was our triangle inequality. Let's pull up that in history. Triangle inequality says that z must be less than or equal to x plus y. Okay, and that's why this one's an error, because it's greater than the sum of the other two. Triangle violates the triangle inequality. Okay, illegal. Side lengths. Okay, triangles violating triangle inequality are illegal too. So this is where, okay. Side lengths violate triangle inequality. That's interesting. Looking at what the README said, this should be okay because it's equal to. Z is equal to. So let's have a look back at the README. Okay, greater than 0, that's fine. Degenerate. Where are we? Isosceles. What does it say? And the sum of the lengths of any two sides must be greater than or equal to the length of the third side. So why is that one? That one I'm not so sure about, because we have x plus y is equal to z. So I don't understand. Okay, triangle inequality, let's have another look there. So we have our longest side is greater than the sum of those two. So this one I'm not 100% sure, but I guess that's probably what it means here with the degenerate triangle. So I think in the beginning what we'll do is we'll implement this and we'll say that the third side has to be less than the sum of the other two. Okay, let's jump into our triangle.exs and we'll take a look at what we've got here. So we've got our type spec up here for the kind of triangle that we're returning. And the function that we need to implement is actually called kind. So we pass in three sides, three numbers, and we either return OK kind or error and a string. So as we did last time, what I'm going to do is just implement the happy case first, the case where we have a triangle that isn't violating any of the rules and we don't return an error. And then what we'll do is once we've got all those tests passing, we'll go through and we'll implement the error cases. So as always, what I like to do is an io.inspect. And what we can do is, let's just do the function and we'll just print out our arguments. And this will help us to implement the function more quickly because we can actually see what's coming in. And we'll just see our call. I'll jump back into the test, jump back to the top, and at the top there's a line of code that allows us to load the module in this file into IEX, and we can start building out the function to work out what's going on. So I've just copied that, I'll paste it down in the terminal, and that's loaded in our triangle module. So I'm going to do triangle.kind, and I'm just going to call it with 111 and just see what it spits out. So you can see there that it's just spat out what we've called there. We've just called it kind with 111. And so now let's start implementing the function. So let's think about the requirements that we have. We have that requirement of the triangle inequality, which is more of an error case, but maybe we want to start dealing with that first. Or we can jump over and just do our happy cases. So we have equilateral, isosceles, and scaling. So we can start implementing functions that will just check for those things, right? So we've got is equilateral, and then we can have A, B, C, and we'll do a little question mark at the end of that, right? Just to imply that it's something that returns a Boolean. So we've got our function is equilateral. We can do is how do you spell isosceles? Let's just copy that. Is isosceles. We can do another one, def p. Actually, is scaling. We have A, comma B, comma C. And what we'll do while we're implementing these, let's just make them public so we can start using them in IEX as well. So how do we determine if a triangle is equilateral? So that's where A is equal to B and B is equal to C. Okay, and that's the full thing. So if we jump back in here, let's reload our code and we'll do triangle dot is equilateral and we'll do 1, 1, 1. And that's true. And if we change one of these to 2, it's false. So we've got our is equilateral function working. So is isosceles. If we look back to the README, the definition of isosceles is where two sides are the same length. Isosceles triangle has at least two sides the same length. It is sometimes specified as having exactly two sides the same length, but for the purposes of this exercise, we'll say at least 2. So if we jump back, it means either A is equal to B or A is equal to C or B is equal to C. So we've got A is equal to B or A is equal to C or B is equal to C. So if we reload our code and take a look, is equilateral, let's change to is isosceles and we'll do 1, 1, 1. So that's also true. So according to the README, it should say at least 2 sides the same length. And if we do 1, 1, 2, that should also be true. And if we do 1, 2, 3, that should be false because none of the sides are the same length. Okay, so that looks like it's working well. So scalene is only a scalene triangle if all the sides are different. So A is not equal to B, and A is not equal to C, and B is not equal to C. Okay, let's jump back in. We'll reload our code and we'll run our isScalene function. Sorry about my keystrokes. I'm using a Bluetooth keyboard and I haven't quite adjusted to it. So isScalene, this should return true because all the sides are different length. And if we change any of them to be the same, it should return false. Okay, cool. So we've got our functions there. What we can do, since we want to do an early return, right? So for example, I can see in the test that if we pass in 2, 2, 2, it's going to return equilateral and not isosceles. So this triangle is also an isosceles triangle because 2 of the sides are the same, but this test is telling us that we should prioritize equilateral first. So what I'm thinking here is instead of having a big if statement, let's use cond, and we'll go is equilateral A, comma B, comma C. We'll return okay and equilateral. So actually this should allow us to pass our first test. So what I'm going to do in this other case is I'm just going to return an error and I'm going to return not a valid triangle. So this is just because in a cond we need to have a default case, and what we'll do is I'll just reload the code and make sure that that function is working at all. So we'll do triangle.kind and we'll pass in 1, 1, 1, and it should return okay and equilateral, and that's our first one passing. So what we'll do is we'll jump back into the tests and we can see that that first one, we actually don't, this test will run first and we should be able to pass this test. If I jump out of IEX, run the test, we should pass the first test. Let's uncomment the second one and we'll see if that test passes as well. We can see that because all the sides are the same length, we should pass that one too. Let's test it. Yep, so we passed that one too. Isosceles triangles. So I can already tell in advance that this test is going to fail because we haven't implemented a path in our condition to check if it's an isosceles triangle. So what we'll do is we'll uncomment that. We'll let the test fail so we can see that the problem here is that we've returned not a valid triangle and what it's expecting is okay isosceles. So all we need to do to make that test pass is we need to have another branch in our cond statement and we'll have is I saw, well, this is difficult to spell, A, comma, B, comma, C, and we'll return okay and an atom of isosceles. And now if we jump back out, let's run the tests again, and that test passes. So first we check if it's equilateral, and that's only if all the sides are equal. Next we check if it's an isosceles, and that's if 2 of the sides are equal. Let's jump back into the tests. So that one passes. Let's check the next isosceles problem. So we have, instead of 3, 4, 4, we have 4, 3, 4. That should return okay isosceles as well. Perfect, so that's passing. Let's have a look. Isosceles triangles have 2 first sides equal. That should also pass. Nice. Let's jump down. Isosceles triangles have, in fact, exactly 2 sides equal. That's interesting. Trolling us a little bit with the test comments. Scalene triangles have no equal sides. And again, this is going to fail because we don't have a branch in our cond, but let's run the test anyway to see what happens. Good. So we've returned error, not a valid triangle, but we should have returned okay scalene. And so all that takes is for us to jump back in here. Let's add another branch. Is scalene A, comma, B, comma, C. And we'll return okay and scalene. Whoops, scalene. Excellent. So now that we have that path implemented, we should be able to run the test again and have it pass. Perfect. So we'll jump back into the tests. There should be a few more scaling ones that we can do. Let's run that test. Nice. Scaling triangles. More scaling triangle tests. Nice. Very small triangles are legal. So now instead of passing in integers, they're passing in floats. And this should also work. All of our conditional statements are just based on equality. They're not really dependent on it being an integer or float or anything like that. So let's run the test, and that should also pass. Nice. Triangles with no size are illegal. So we haven't implemented any error checking or validation in our function. So this one will fail, and we'll see here. So we've returned OK equilateral, and that's because all the sides are equal, but really what we should be returning is error, all side lengths must be positive. So what we can do, since we're using a cond, we could do it in here. We could do a guard clause, and we could say when A is greater than 0, B is greater than 0, etc. But I think it's going to be a whole lot cleaner if we write an isValid function for A, B, and C, and then we just have a cond that basically checks if it's invalid and returns the error if it's invalid. So what we can do here is we'll do another def. I'll change these to def p later, so they're private. But what we can do is valid triangle, and we'll pass in A, B, C. So to check if it's a valid triangle, first thing that we're going to do is we're going to say A is greater than 0, and B is greater than 0, and C is greater than 0. So we may have additional things that we want to check later, but for now we're just going to check those things and get that next test passing. So the next condition that we're going to do is not is valid triangle, and we're going to pass in A, B, C, and if it's invalid, we're going to return an error. And actually this is a more specific error. All side lengths must be positive. So really we should change this to something else. All side lengths must be positive. So what we can do is we'll just change this to all side lengths positive. Okay. And if we have not all side lengths positive, what we'll return is error. All side lengths must be positive. And that should allow us to pass the test. Let's check that. Beautiful. Let's jump back into the test and see what the next one is. Triangles with negative sides are illegal. So that should also be covered by our little check that we made there. Nice. Triangles violating the triangle inequality are illegal. So this one we haven't implemented yet. Let's comment that out and run the test again. This will fail. So what have we returned? We've returned OK isosceles, but the problem is that the side lengths violate the triangle inequality. One of the sides is greater than the sum of the other two. So what we'll do here is we'll implement another function. I'm going to call it, let me implement it under here. We'll call it triangle, what do we call it? Triangle violates triangle inequality. A, B, C. And maybe since we want to follow the pattern of not, let's change this to meets. Triangle meets triangle inequality, and what we'll say, this might be the most complex function we need to implement for this one. Basically what we need to see is whether two of the other sides, right, the two other sides are greater than one of the sides. So what we need to do is we need to go through all of the sides, but we also need to make sure that all of the other ones don't add together to be greater than that. So I think the best way to do this will be if we pass in a list. So let's do A, B, C, and let's do enum dot with index, So it's going to give an index to each one, and that's what that's going to allow us to do is in enum.reduce, we'll do enum.reduce, we'll say that the accumulator is true to start off with, and then what we're going to do is implement a function that has side, index, and it's also going to receive the accumulator. And what we're going to do for each side and index is we're going to check the other indexes and work out if the other two indexes are greater than or less than the one that we've passed in. So for instance, the first one that we're going to get in is we're going to receive A and an index of 0 in a tuple, and we're going to receive true in there. And what we want to do there is we'd like to run the comparison that A is less than or equal to B plus C. And in order to get B, what we're going to have to do is we're going to have to filter out the other indexes. So actually, I think what we're going to do here is we'll do this. We'll do sides with indexes, so we can actually reference it. Sides with indexes, and then what we'll do here is to enum.reduce, we'll do sides with indexes. And what we'll do first is other sides, and we'll do an enum.filter. So what I'm going to do is remove the current side that we're on based on the index. So actually that's going to be enum.reject. So I'm going to reject out of the sides with indexes. Sorry, my keystrokes are so poor. Sides with indexes. And what we're going to do is a function that takes the side, index, and we don't want this, we don't care about the side. All we care about is the index. And we're going to return true when the index is the same as the current index. So I really should change the name of this. So we'll call it side to check, and we'll call this index to check. And we'll return true when index to check is equal to index. And what that's going to do is that's going to reject the current side. Okay, so with A, it's going to receive an index of 0, and it's going to, out of here, get rid of all of the sides where the index is 0, which is just going to leave B and C. So we've got other sides, and this is going to be other sides with indexes. And what we'll do here is because this function is starting to get quite complicated, we're going to start building it out in IEX. So I'm just going to put an ia.inspect in here. And what we'll do here is also just an ia.inspect here. And we'll jump back into IEX, and we'll just start building out that function to make sure it's doing what we expect. So I'm going to load that file. We're going to do triangle meets triangle inequality. We'll pass in 1, 2, 3. And we can see here that in the first one, we've got the side of 1, index of 0, side of 2, index of 1, side of 3, index of 2. And then for each iteration, these are the remaining sides. So in the first iteration, this one's getting passed in, and these are the other sides in there. We've got the side of 2 and the side of 3. Here we've got, on the second iteration, this is the side in question. We have the side of 1 and the side of 3. And then in the final iteration, we have this item as the item in question, and the first two are it. So what we'll do, now that we've got that in there, we've got the index to check, that's fine. Other sides with indexes. What we want to do is we'd like to get the sum of the other sides and compare it to the current side that we're checking. So sum of other sides. This should work with an enum.sum. I'm just going to check enum.sum to see if we're able to pass in a function that will return the amount. No. So we're going to have to do another enum.reduce. So we'll do enum.reduce other sides with indexes. The original will be 0. And then in our function, Each one is going to receive side to add and the index, which we don't care about. We don't care about the index, we just care about the side to add. And we're just going to do the accumulator, which we also need to pass in as an argument. Accumulator plus side to add. And that's the end of it. And what we'll do, format the code. Let's chuck another inspect here. And we'll reload the code and we'll see what comes out. So reload that. Let's run that triangle meets inequality function again. And you can see here that for our first iteration, we've got 1 and 0 as the item in question. We have side of 2 and the side of 3 being added together to equal 5, right? Which is greater than 1. The next one we have is the side of 2 in question. And we have 1 and 3, which is 4. And then the final one is that we have 1 and 2, and that adds up to 3. So I'm just thinking now, the way that we've implemented it isn't necessarily correct, because really what we want to check is the largest one, and we want to add up the other two. So I've actually taken a totally incorrect approach to this function. So I'm going to back out of it, and what we're going to do instead is we're going to find the largest amount, and we're going to get the index of that, and we're going to find the sum of the other indexes together to see if it's less than the maximum side. So let's get rid of this. We still want the sides with indexes, right? We still want that because we still want to know the index so we can remove the other sides. Because if we have all the sides the same, we're going to remove, if we just remove them based on the number, it's not going to be correct. So if we just return the function to this, you'll see what we get out. So we have our sides with indexes, that's fine. Now what we need to do is find the maximum value in there and the index. So I'm just going to check if our enum.max allows us to, yes, so we have a max by. So we have the enumerable and a function that we can pass in to return what the number is that we want out of there. So let's go max side and then max side index. This is what's going to get returned out, and that's going to be enum.max by. I'm really sorry about my keystrokes, guys. So that's max by, and we have sides with indexes, and the function that we're going to pass in is going to receive all the items. So we're going to have side index, and we don't care about the index. What we just want to return is the side, because this is what we're telling max by to use as the number to get the maximum of. So let's do that, and we'll just pipe that to inspect. Let's reload the code. Cool. So this has, as we expected, the max side and the max side index is we have 3 and 2. So the maximum side length is 3, and the index of that one is 2. So now we need to re-implement our other sides variable. So the other sides is the enum.reject, sides with indexes. And we have our function that accepts the side to check and the index. And actually, that's all we want. Index to check. Get rid of that one. And what we want is index to check is equal to max side index, and that's the end of that function. Let's format the code. Let's inspect that. Let's jump back in, reload the code, run it again. So we can see here, we've got all of our things that we passed in, the maximum side, and these are the other sides. And then all we need to return now is, since we have these other sides, we need the sum. So we'll call this sum of other sides. And since we have a sort of strange arrangement, since we have 2 tuples and we just want to add the first number in each tuple, see here, we don't want to add the 0 or the 1. We don't care about those. We just want to add 1 and 2. What we're going to do is enum.reduce, like we did before. Enum.reduce other sides. And let me just change this so we're clear with indexes. I just like to make sure that our function names are as clear as possible. This is fine. Some of other sides with indexes, and we're going to pass an initial accumulator of 0, and our function is going to take the side, the index, which we don't care about in this case, and the accumulator. And what we're going to do is we're going to do accumulator plus side and end. And as always, we'll just chuck an io.inspect at the end of that, format the code, reload the code, run that function again. And you can see here now that 3 there is our sum. And the one thing that we want to return is max side is less than. So we don't want it to be equal to, just because what I saw in the tests. Okay, I've just seen in the stream chat for Twitch that you just throwing it out there that checking triangle inequality theorem requires precisely 0 loops. You can represent it as a single inequality. That's interesting. All right, so once I implement this, what I'll do is I'll go through and I'll see if I can represent it as a single inequality. I wasn't aware of that, but we'll see what we get to. But first, I'll just implement it this way. And I can see here that, yeah, since we're checking all of these, that it may be possible. So in here, the triangle inequality, let's see here. Let's just do max side is equal to sum of other sides. And if this is working, what we'll do is we'll try and represent it as a single inequality. Thank you for the feedback in the chat, by the way. So that should be false. And we'll see if I can work out in my head if we can do it. Single inequality. So that would be what? A is less than B plus C, and B is less than A plus C, and C is less than A plus B. So actually may be the correct way. Okay, yeah, I see. You've just, yep, exactly right. So let's comment this and we'll see if it gives us the same result. Okay, we do 1. Okay, and if we make that 3, that should be true there. So I think I've done the wrong side. So it should be, nah, see, that's not true. Yeah, I've messed up there. So A plus B is greater than C, A plus C is greater than B, and B plus C is greater than A. Is that going to be true though? So let me just put in the comments. So if we have 1, 2, and 3. So, oh yeah, no, it will be greater than. Yeah, you're absolutely right, because they always have to be greater if the triangle inequality is true. So let's see here. B plus C is greater than A. That's true. A plus C is greater than B. And A plus B is greater than C. If we reload the code, right, that's false. That's false. Wait, this one should be, that one should be true. Should it not? What have I messed up there? B plus C is greater than A. Blah, blah, blah. I have reloaded the code, haven't I? So that should meet the inequality, shouldn't it? No, because 1 plus 1 is not greater than 3. So what's a valid triangle would just be 1, 1, 1, right? And that will return true. And obviously, like any equilateral triangle, right? Let's make this 1.5, for instance. That's also true. So I believe that is a much simpler representation of what we wanted to do. I'm just going to leave that in there commented, and we'll see if we can pass all the tests with that. Let's jump back out. Let's run that triangle inequality. So this is because we haven't implemented this in here. We'll have not triangle meets triangle inequality, and actually we do want to pass in those arguments too. Let's just jump back, paste that in there, and what we want to return here is an error, and we'll just go back into the triangle tests to make sure what the string that we want to implement is. So it's side lengths violate the triangle inequality. Okay, so now we have a path in there. And we've passed the test, and we only have 2 tests left. Triangles violating triangle inequality are illegal too. Okay, very nice. And triangles violating triangle inequality are illegal 3. We'll test that too. And all of our tests are passing. So thank you very much, Stream Chat, for helping me out there. I was going down another path here. So this was my non-mathematical mind trying to implement it naively in programming. I had some help from the chat to implement it properly. So the original path that I was going to go down was to pull out the maximum side and then compare it to the sum of the other sides. So it's actually much easier just to do in an inequality in here. So for instance, if we have a legal triangle of 1, 1, and 1, right? This meets the triangle inequality because, because 2 sides are always greater than the other side. So 2 is greater than 1 in all cases, and we return that. If there's a case where we have 3, this is illegal. It's impossible for a triangle like this to exist because if you have 2 sides of 1, the other side can't be 3. The maximum that it could possibly be is 2 if it was a straight line, right? And even 2 is wrong because that is just a straight line. There is no angle. So yeah, we did it. Very nice. And if it's, for example, if it's 1.5, then we do have an angle in there. So this is legal because 1.5 is, so 1 plus 1.5 is greater than 1, 1 plus 1.5 is greater than 1, and 1 plus 1 is greater than 1.5. So that meets the inequality. I'm going to get rid of all my messy, naive code down here. And what I'll do, since we're passing all the tests, is now that we've implemented all of these as public functions, just so we could test them in IEX, what I'm going to do is put them all to def p, because really they're private functions. We don't need to expose them publicly. And the only one that we need to expose publicly is our kind function. And I'm going to remove this io.inspect up here. Save it. Let's go back. We'll run our tests again. And we can see here that we have 15 tests, 0 failures. Let's check for any warnings. There are no compilation warnings, so I think we're about done. Just a quick recap of what we've done in the kind function is we've just implemented a cond. So this is just a conditional switch to check are all the sides positive. So if we have not all side lengths positive, A, B, and C, we return an error. If the triangle does not meet the triangle inequality, we return an error. Then we go down and we've prioritized equilateral. So if it's an equilateral where all the sides are the same length, we return a tuple of 2 atoms, OK and equilateral. If it's an isosceles, we do OK and isosceles. If it's a scalene, we do OK and a scalene. And then we just have our default case in the conditional, which returns an error and not a valid triangle if we don't have anything that meets these other conditions. And then down here, we just have our single private functions that do all of our little checks. So what we could do if we wanted to really minimize these things is we could make them one-liners. So we could do something like that. I generally prefer not to do that. So even if we have a very small function here that we could have as a single line, if you have more than it's just returning one of the arguments, I like to have it on its own line, since you may want to add some things later, and I find it slightly more readable. So this is about as clean as I think we're going to get this function. We might be able to optimize some of the names, but I'm pretty happy with this. Let's run the test again just to confirm, and I'm ready to submit it with Exercism. And so what we just have is our triangle.exs. Whoops, I need an Exercism submit. Oh, my keystroke's so horrible. Got to get my spacebar fixed on my laptop. Okay, excellent. So we've finished that one. Exercism should give us a nice little congratulations here. Well done on solving this exercise. That's in there. I'm going to complete the solution and publish my solution. And what I'll do is I'll put a link to my solution in the article that I post on Twitter, YouTube, Twitch. I'll just update the descriptions later. And I'll also write an article on toptechskills.com. So you can see here in toptechskills.com in the Elixir and Phoenix tutorials part, I've got my exercism solutions and tutorials. Yesterday's solution was the Hamming problem. What I've just done here is post my solution video and just an explanation of the way that I approached it. So if you don't want to watch the video, you can just read through and see my approach. So I think we're all good. So thanks very much for watching, everyone. I'm going to try and stream every day at around 11 a.m. GMT plus 8. If you enjoy it, please like the video on Twitch or YouTube. Please check out toptechskills.com and maybe follow us on Twitter. But otherwise, we'll see you next time. Thanks very much.